To get good results with thread milling, it is important to get two things right. You need to select suitable thread mill and cutting data. One reason our customers get very good results is our software for thread milling, SmiProg. SmiProg is a simple yet very powerful thread milling software. We will now take a closer look at the basic features of SmiProg and see how the different options can help you choose the most suitable thread mill for your application. First step. Choose your language. We stay with English for this video. SmiProg includes an additional sheet with important information about how this software works. Click here to read this information in your language. For the basic features of SmiProg, we only need to check or fill out this space here to get the cutting data and programming code. Let's say we want to make the thread M16 with a thread length of 32 mm. The material we are machining is a type of medium carbon steel. First option is which type of thread milling we will do. You can choose between internal thread milling in lathe with live tool and internal thread milling in machining center. We choose the most common one, internal thread milling in machining center. Next option is the control system we are using. SmiProg supports both Fanuc and Heidenhain. We let it stay as Fanuc. If you have another system, you may choose Fanuc as it is ISO programming. If you only use SmiProg for cutting data, it doesn't matter what you choose here. Now we have to choose the type of thread. M16 is a metric thread. Here you can see the different materials to machine. We choose steel, medium carbon, as we said earlier. Square 1 to 4 is where we specify our thread dimensions. Thread diameter is 16 mm and the pitch for a coarse M16 is 2 mm. We press enter. The third square is for the thread length, which is 32 mm. The safety distance in square 4 is to define the start point of the CNC program, as you can see in the picture. We leave it as it is. The last thing to do is choosing the thread mill we will use. As you can see, there is a lot of choices of thread mills that can make this thread. The thread mills that start with NB is the most common thread mill from SmiCut. They are without internal coolant. NBK is the same, but with internal coolant for blind holes. And NBT is internal coolant for through holes. We choose this one, NB1212D35. It is a 12 mm thread mill with a cutting length of 35 mm. To get best performance, we select the thread mill with biggest diameter and shortest cutting length. We now have cutting data here in this part of SmiProg. We also have the time it takes to mill the thread, 9.2 seconds. And we have the CNC program here. You only need to select it, then copy and paste it where you want. But what happens if we choose a thread mill with a smaller diameter? We see in this list we also have a 10 mm thread mill that can make this thread. We select NB1010C37. You can see the CNC program changed. With a smaller thread mill diameter, SmiProg now recommend different cutting data, and the time it takes to make the thread mill has changed from 9.2 seconds to 20 seconds. we change back to MB1212D35. The cutting data also changes if you choose a different material. For example, we change material to hardened steel. The thread is now made in 2 passes. You can see the CNC program is longer. The time it now takes to make this thread has increased from 9.2 to 28 seconds, as the material is more difficult to machine. Now you know how to use the basic features of SmiProg. Download SmiProg for free from our website. You can find the link below in our description. With ThreadMills from SmiCat, you can get the threading and the deburring done in one operation. In the third part of this series of videos, we will see how to make use of this feature in SmiProg. We will also look at how to get the correct thread diameter right from start. Thanks for watching, and subscribe to get notified about future videos from us.